this circuit that you see has the capability of absorbing energy from its surroundings, and that energy is available in the form of radio frequency signals from cellular towers, Wi-Fi signals and all, and then convert that energy to electricity and then storing that electricity in these capacitors, the orange ones that you see. And this is 100% correct. And I'm going to practically show you everything in this video. Here you can see that I've pointed the multimeter at DC voltage measurement mode and it is at 0. Now I'm going to connect this circuit to my meter pinouts. Red is positive and black negative. You can see that the voltage is increasing little by little and there is no power source given. It is still rising. How is that? This is because this point that you see is acting as an antenna, which is absorbing radio frequency from the surroundings and converting it to electricity and thus storing the charge in these two capacitors in the form of DC voltage. Right now you can see that the charging is only in millivolts, which is very less. We have charged it to 12 millivolts. Now we need a bigger antenna. Now my body is also a conductor, so it is also going to act as an antenna. So let's touch it. And here you can see that now the voltage is rising rapidly. We have crossed 160 volts DC because the antenna is getting a bigger surface area. And this also depends on the number of cellular towers and how close they are to this device. So here you can see that we have achieved around 400 millivolts. Let's see the max to what it gets. So here we have reached zero point 0.6 volts and it is still rising. Seems like 1 volt is quite close now. And you can also imagine the voltage that is being lost across these diodes, the number of diodes that are connected in series. But these diodes are necessary for converting the AC signals to DC. Now the charging process has reduced quite low. I had hoped that it would at least go to 1 volts, and as you can see that it is maxing out at 889 volts DC. Yeah, 900. Now it has again started to rise quite rapidly. And finally, we have crossed 1 volts. And it is still increasing. Now I'm going to remove my hand and you should see the voltage. And here you can see that the voltage is falling really fast as I disconnected my fingers. And once again, if I'm going to connect it, it is going to start rising. Now, this is my camera stand. And at the bottom, you can see some cardboard that is for isolating the tripod from ground. And this tripod is going to act as an antenna. And here you can see this wire. On one end, I have this clip and the other end is bare, nothing. So this clip end will be connected to the tripod as an antenna. And the bare end will be connected to the socket. Now the meter is showing 0 volts DC, and here I'm going to connect the antenna wire. Yeah, but let's first connect these wires. Yes, see it is showing 53 millivolts. So let's discharge it first. And as soon as I'm going to remove the wire, it is going to start energizing and charging once again from 0. Wire is disconnected and the capacitors have already started charging 10.8 and increasing. Now let's finally connect the antenna wire. And now there will be a quick increase. Go. So as you can see here that there is a rapid increase in the charging voltage. Let's see the max that we can achieve here. Now, I'm not sure that when I'm touching the wires, the voltage is increasing a lot further. No idea how that is happening, but it is intriguing. Voltage has increased to 1.7 volts and it is charging really fast. Whoa, we are closing at 2 volts. Oh, that is so cool. And I'm removing my fingers, and here you can see that the voltage is like reducing. Like initially, I thought that there was this wire that was loose, but I think that something is happening when I'm touching it with my fingers. Let's see the maximum that we can do here. Very close to 2.5 volts. Whoa, 3.5. Once I remove my fingers, it is discharging. Something is happening with my fingers. See? Weird. Oh, now I get it. My body is connected to the ground, and when I'm touching this wire, so we are getting an AC signal from here, and here it is ground. So it is charging the capacitor really fast, and it is getting this polarity, which means that it is better when you are going to use this kind of circuit. You will need some ground. Seems like we are stabilizing at around 4.5 volts. So here I'm going to do this little experiment. I have connected this small buzzer as you can see and the circuit, and the voltage here you can see is 460 millivolts. So one thing that we can notice is that without the ground wire, the capacitors are not charging quite well. So here I'm going to connect my body once again, same as before, and you can see the increase, the drastic increase. We have reached 1.8 volts, and once I'm going to connect this wire, which is the positive to the positive, then we should hear the buzzing sound, and for that I'm going to bring the mic closer to the buzzer. Here it is. This time it is going a little higher. Yeah, 4.5 still. And that needs to be more close. Was that told to me? It is going to be much higher. And go. Yeah, see the drop in voltage, and if I keep it connected, nothing. And once I disconnect, can see that the voltage has started rising once again. And once again, if I connect it, let's wait and let it charge to the max. Yeah, I think this is it. On go. The voltage has dropped to zero point 0.4 volts. Next, here as you can see that I've connected this small LED. It is green in color, and I'm going to charge it once again with my body being the ground. And let's test the LED. Yeah, I think that's enough. And I'm going to touch this clip to this one and go. It was a blink. I'm going to do it once again for you people, just in case if you didn't see it. And this time, after seeing this, you should also notice the drop in voltage of the meter. Go. See, dropped to 1.945 volts, and now the LED is not glowing at all. It is 2 volts, so it should be glowing. The voltage is not going. Oh, there is this little brightness. So this time I'm not going to disconnect the wires of the LED and simply going to touch my hand. Oh, I believe you people must be seeing this. A little glow from the LED is what we are getting here. It is lighting up, but it is very dim. Let's touch it from this point. It should work same. Yeah, how about this one? Same. So as you saw that this circuit produced a voltage of around 4.5 volts, which was pretty good. So many of you might be thinking that, wow, 4.5 volts, so we can charge our cell phones because they also charge at that voltage value. But no, you cannot run many things with this because the overall current that is produced through this circuit is very low. Assume that this is an electromagnetic wave transmitting tower, just like your cellular tower or your FM radio tower. And this one is a receiver that converts your electromagnetic waves to electricity. Now, there is a red LED light on the transmitting tower, and I've also connected this red LED light load here. You can see. And now I'm going to turn on the switch, and this should receive electromagnetic waves. You see? On, and here we have it. And this is happening wirelessly. No wire given, everything wirelessly. Let's turn off one more light, and I believe you can see better. And once I turn off the transmitter, they both go off. Now, before you guys start thinking of this as a fake video, let me tell you guys that this is just for demonstration to make a very important point that is going to come next. And this transmitting tower has nothing to do with this receiving end. Now, this is my supercapacitor pack. It can charge from 0 to 12 volts. So the next part becomes quite obvious, which is storing the received charge from the receiver to this capacitor bank. Finally, I'm going to use this DC fan because the capacitors, the supercapacitors, should have charged by now. And this is true that this circuit is drawing power wirelessly and charging the capacitors. Cool, right? Now, this is the basic criteria on which Maxwell Chikumbutso's inventions rely on, and they somehow remind me of Nikola Tesla, who wanted to build this big power transmission tower and then transmit electricity to the receiving end. Now, the great difference is that Tesla wanted power transmission from the transmitting tower to the receiver. Like this is the transmitting tower, and Tesla wanted to transmit power from the transmitting tower to the receiver. Whereas what Chikumbutso claims that he did is use the power from the radio frequency towers. Now, here is a great catch. The radio frequency towers are not designed for emitting large amount of frequency. And so they cannot deliver that much amount of power to a receiving end because they are designed for information transfer, not power transmission. Let me explain this to you in a simple way. The transmitting tower emits photons, and these photons carry energy, and this energy is given by the formula E is equal to hf. H stands for Planck's constant and F is for frequency, which shows us that energy for the photon is directly proportional to the frequency. Higher the frequency, higher is the power transmission. Now, the second most important pointer that is actually going to nullify the claim of Chikumbutso's inventions is the inverse square law that applies to someone who has traveled a distance from that transmitting tower. And this happens because the tower is not pointing electromagnetic waves in a very specific pointed manner, just like a laser light. It is spreading it in a spherical manner all around us. So it is not dedicated to a specific point, and thus it is going to reduce as we move step by step further from the transmitting tower. Now, unless Chikumbutso has actually built his power station just below the transmitting tower, and even then, a single transmitting tower is not going to prove that his invention is 100% correct, because then again, the tower is spreading the photons upwards, this side, and some to the bottom. Now, this method can actually work for Chikumbutso only if he has somehow convinced the telephone companies and the FM broadcast channels to focus all the electromagnetic waves to a single point, which is Chikumbutso's lab, or the place where he is actually powering his stuff. Because if we are focusing electromagnetic waves at a certain point, then this inverse square law is not going to apply. Even if he has convinced the telephone companies and broadcast companies to direct all the electromagnetic waves to his residence or lab wherever he is working, there are going to be difficulties for the traveling waves because there are big buildings and moisture, dust particles, and trees, birds, etc., that are going to hinder with the radio frequency waves, and thus reducing the intensity from the transmitting end to the receiving end. And now comes the most important pointer on how to make it actually work. As I said, the first thing is lesser obstacles between the transmitting tower and the receiving end, number one. Number two, all the transmitting towers, even if it is broadcast tower, cellular tower, FM radio tower, they have to focus all the electromagnetic waves to a single point, which is going to be the receiving end. Number three, increasing the frequency of the photons. The electromagnetic waves are made up of large number of very small photons, and these photons are charged at a certain frequency. This frequency has to be really high. So that's all, guys. See you in the next video. I hope you got my point from the video. If you have queries, you can always ask them in comments. Bye bye.